morning, good afternoon. A warm welcome to all our attendees today from across the globe. Thank you all for joining us today for this webinar on failure-proof test automation of mobile apps. This webinar is hosted by Impetus Technologies, and we are excited to have you with us for the next 30 minutes. We hope to have a fruitful and engaging interaction today as we discuss how test automation of data-centric consumer and enterprise applications can help reduce the cost and time involved in application testing. I am Garima Arora from the Impetus marketing team, and I will serve as the facilitator for this session. Joining me is Amitabh Srivastav, Senior Solutions Architect, Mobile and Wireless at Impetus. Amitabh has numerous award-winning mobile applications to his name. So moving on to what today's session is going to cover, the global mobile applications market is growing at a CAGR of 64% and is expected to reach $24.4 billion by 2015. With more than 5 billion active mobile connections globally right now, this figure is only expected to increase. The complexity of mobile applications is growing along with the device capabilities. Test engineers have to address multiple challenges while testing data-centric mobile applications. These include diversity in device features, platforms, and technologies. The test engineers have to deal with enormous number of case study test cases while simultaneously dealing with tight deadlines. They also have to deal with technical challenges such as API-level test execution and verification of UI control. In our session today, we will discuss how testing automation can help effectively address all these issues. We will also cover the various types and approaches of test automation, how it works, and its benefits and constraints. We will also share with you our failure-proof approach to mobile application testing automation, along with some real-world examples. I would now like to invite Amitabh to take over the presentation. Amitabh is heading the mobile R&D initiative at Impetus and has shared his experience and expertise in numerous forums and events. Over to you, Amitabh.
Thanks, Garima, and a big hello to our audience. Thank you for taking time out to attend this session on testing automation of mobile applications. Now, before I start with my presentation, let me share an anecdote with you all. It was in early 2004 when I was working on a mobile healthcare product for a US-based healthcare company. All through the different phases of the development lifecycle of the product, there were people in the company who were testing the app on their Singular, which is now AT&T devices, and everything was working fine for them. Then they made a soft launch of the product, and the same was accessible through their website. However, we immediately started getting complaints from some of the alpha users sharing that the apps were not able to connect to the server on any other network except Singular. So it works if they use a Singular SIM card, but it was failing if they are using T-Mobile or they were coming to Verizon. At that time, we did not have an option to actually run the app on various devices of different operators and run some kind of automation testing to identify these issues remotely and fix them. So I had to fly down to US, perform some manual testing, debugging on the different devices in the different networks, just to find that there are some very minor issues with change of some special characters in the network communication when the data was passing through the WAP gateways of the different mobile operators. From that day, I started thinking on the lines of automated testing framework for mobile apps that would enable us to carry out this type of testing on devices connected over the air in some target operator network remotely so that we can debug the apps. Let us now share with you some of the generic challenges that we see when we try to achieve such kind of mobile testing. There are overwhelming number of handsets available in the market today, ranging from your basic phones to feature-rich smartphones and tablets like iPad and others. The basic challenge that the test engineer encounters is due to the diversity of the devices and the platforms. Each mobile handset has a different hardware configuration, display size, color depth, memory, computing power, and different hardware capabilities. This makes it imperative to run manual tests on all configurations, thereby making it a very time-consuming task. With the growth of hardware capabilities of the mobile handsets and the network speed, highly complex mobile applications are being developed nowadays, which require a very thorough and intense testing. Then again, most of the mobile platforms lack the basic functionality and the interface that allowed automated UI testing in the desktop world. So all the currently available desktop automation tools are rendered useless if we try to use them for the mobile apps. Client-server applications written for mobile devices depend upon the network and behave differently in different types of carrier networks. So there is a definitive need to remotely test these apps in the actual target network. The product owners are mostly rushing for getting their product launched the moment they get an idea, thinking that it's a mobile application, it's something small and it can be developed quickly. Consequently, they force their engineers to reduce the time to market by adopting accelerated software development schedule, leaving no room for any testing, which often results in suboptimal testing and lower quality of deliverables.
Amitabh, won't there be any serious repercussions of such practices?
Yeah, indeed there will be. But it appears that we like to relearn the basics of good software engineering again at a huge cost every time there is a paradigm shift. Let's move to the next slide, which is about the technical challenges. As the complexity of the application is growing with the device capabilities, we see more and more number of test cases coming in the scope of testing the application of mobile handsets, which makes the manual testing of the application on different devices very time-consuming and repetitive task. Various API level test cases are defined that need to be tested using unit testing, which in turn require automation. But due to lack of reflection capabilities on most of the mobile device platforms, unit testing automation is not possible, and we need the developers or the white box testers to write large number of test scripts that again takes time. Application interface of the same product often contains differences when implemented by different developers on different platforms depending upon the target OS. As we try to follow the UI guidelines of different platforms, it ends up having certain differences for the same app on different platforms, which confuses the test engineers further when they are verifying the same test case on different devices. There are a number of non-standard APIs and proprietary solutions such as playing sound, access to external port, or current displayable on different platforms that needed to be taken care of when testing. At times, these even require a special set of tools for testing as well. And on this note, I would like to ask the audience, what is the biggest challenge that they encounter while testing their mobile apps?
Our audience can now see the poll questions running on the screen. We want to know the major issues that you face while mobile application testing. Your options are diversity in technology or platforms, career-related issues, large number of test cases, technical issues, or all of the above. You have a total of 30 seconds to respond. We have collected the responses, Amitabh, and apparently our audience think that the biggest challenge that they encounter is the large number of test cases that they have to deal with despite tight deadlines. What's your take on this?
I think it's a similar problem that everybody is facing in the industry. Nowadays, as the mobile handsets are becoming more powerful day by day, the applications which are coming to the mobile devices are more complex and they require large number of test cases to be executed, which is a big problem to do on a mobile device manually, and hence most of the people are trying some kind of automation to achieve this in a better way. So let's move to our next slide where I'll talk about the testing automation itself. This is the time of smartphones and tablets. Mobile phones has come a long way from the days of your basic handsets and so have the corresponding ecosystem. These ecosystems are evolving mostly in the same manner as that of the desktop world. As a result, testing these products is now no longer a simple process and requires some solid procedures with emphasis on automation in both UI and unit testing to assess and evaluate the products. Thus, I can say that testing automation of mobile application is the real solution and need of the hour to maintain the quality of the deliverables of mobile application with ever-growing complexities. Testing automation is defined as the use of strategies, tools, and artifacts that reduce the need of human involvement on repetitive testing tasks. It should support unit testing automation, UI testing automation, and functional testing automation. But will manual testing be become redundant? No, it will not be removed 100%. We will still require some amount of manual testing. And as we move to our next slide, we get to know that when we require manual testing and where we can automate much. Selection criteria. So based on the analysis of benefits and constraints of the mobile application testing automation, we can safely say that the mobile testing automation is useful and should be adopted for data-centric mobile apps such as Salesforce automation, customer relation management, and other enterprise workflow apps where there are large number of test cases and data generated by the system for automation. But manual testing is however very much required for the applications that are highly dependent upon the device capabilities with features like GPS for location-based services, camera and multimedia, or the VoIP apps. Let's move to the next slide where we talk about various types of automation that we can go with. So mobile testing automation can be divided into three parts: unit, UI, and functional testing automation. Unit testing automation is generally based on the popular XUnit family of tools like JMUnit for J2ME and Android platforms, BUnit for RIM BlackBerry, and OCI unit for iOS, iPhone, and other iPad kind of devices. UI testing automation is generally achieved by VNC-based tools that rely on screen or image comparison on a desktop connected with a test device via cable or a Wi-Fi network. And functional testing automation, which is nowadays the best approach, is a combination of unit test type scripts with support of instrumentation on emulators or the real device. For example, nowadays the Android SDK provides an instrumentation support for JMUnit like test scripts that can be executed on the Android SDK emulator on a test engineer system's desktop, or even the build environment, integrated build environments like Hudson. Similar kind of SDK instrumentation is available for iPhone, Xcode with iOS phone now. Let's now move on with how we can enable automation in a step-by-step process. So it starts with writing application-specific test cases. The next step is conversion of these test cases into test scripts. This process is traditionally done manually, but a good automation system should allow for auto-generation of test scripts based on the test cases. These test cases should be written in a certain fashion on an Excel sheet and in a manner that even a black box tester can write or use it for unit test automation. In case of functional testing automation, recorded playback feature should be provided by the framework or the automation tool that allows recording of the test case scenarios while they are executed on the target device for the first time. These are then made available on the test engineer systems in form of test scripts that can be modified to add more test data and scenarios. This is very helpful in case of testing of the data-centric workflows and enterprise apps where there is large number of data-specific test cases. These updated test scripts and the test scenarios can then be executed repeatedly on multiple devices, on local or remotely connected devices, which is termed as playback. Generally, we integrate the automated testing process with some continuous integration environments like Hudson, so that whenever there is a new check-in in the source control by any developer, a new build is generated, all the existing test scripts are executed again on the new build without any manual intervention. This means that the new code base is inserted and reports are generated. If any of the test case fails, the build is assumed to be a failure and an email is sent to all the project team members so that if there is an issue, it can be fixed immediately by the concerned person. So what do we get by doing automation in this step-by-step way? Let's go to the next slide. So the test automation based on test scripts that are programmable to simulate the test any conditions. They provide different set of data inputs and check the results of those extreme cases which at times may not be possible to test with manual testing. This is a big blessing for data-centric enterprise mobile apps where thousands of test cases are generated by the system due to different combinations of data, and it becomes virtually impossible to run all those scenarios manually on every iteration. The test scripts, once developed, can be executed multiple times on the same or different devices, thereby providing us the benefit of repeatability and reusability. These scripts, once created and verified, can be executed with the help of automation frameworks on the target device in a reliable manner without any remote chance of human error, and gives us a comprehensive results on every execution. The usage of automation framework increases the productivity of our QA teams and reduces the overall cost of development for a quality product. The defects are exposed just in time to a developer when he commits his code, enabling him to fix the issue then and there, which is very important in this era of rapid application development. With all of those in place, adopting test automation increases the quality level of the deliverables and helps the developers to achieve perfection in his work. So let's move to our next slide where we discuss that where testing automation does not work are some of the constraints. Like every coin has two sides. I agree that mobile application test automation can be boom for your test engineer, but it is ineffective in regression and negative testing, which may arise due to external environment like out of network coverage area, low or the battery drain of conditions, and such similar scenarios which cannot be controlled directly by the software. These conditions require manual intervention to bring the device back to its normal running conditions and therefore cannot be automated. Automated testing cannot be used for testing the application that utilizes the device hardware such as camera, accelerometer, proximity sensor, GPS, and Bluetooth. These types of applications require physical interaction with the device, and the software-based automation tools will be ineffective here. Manual testing is also required for interrupt testing, such as the cases of the incoming calls and SMS. There is a need of some level of interaction with the mobile operators to generate a call or SMS, which again is a complex for a typical mobile testing automation tool set. Applications that use voicemail or IVR cannot be tested completely with the automation framework, as they depend on other third-party remote systems to perform their normal operations. Network latency at times has adversely affected the entire show of automatic testing on remote devices connected over the internet via GPRS, as in some of the scenarios, the GPRS connectivity speed itself becomes so slow that it hinders the execution of testing automation on a remotely connected device. I would now like to ask you all another question. Has your automation initiative failed due to provide the desired results due to any of the constraints or the bottlenecks that we have discussed on this slide?
We need our audience to respond to the poll question that been now seen on the screen. Have your test automation initiatives failed to deliver due to the various constraints that we discussed? You can see the options on the screen right now. You have a total of 20 seconds to respond. Our audience have an option to choose multiple answers. We have the responses on the top, and apparently regression testing has been the biggest challenge area for our audience. What is your advice to them?
Even in my past experience, I have seen the regression and the negative testing as one of the bottlenecks in mobile testing or application automation. And this is just because these cases cannot be controlled directly by software, and these automation tools are nothing but the software tools, and we require human interface with that, like where we can get the device back to the normal conditions before going ahead with our testing automation tools on it, and hence we cannot do much there. But yes, it's a boom for data-centric application test cases, so we should concentrate our automation effort on automation of the test cases where there is a lot of data and functional testing is required. I would like to invite you to approach us for a pre-consultation of any issue that you might be facing in your testing automation initiatives. Send us an email to inquiry@impetus.com and we'll get back to you. Let's move on to our presentation, the next slide, which is about achieving automation. Here I would like to share with you all some best practices of testing automations now. A good testing automation framework should provide the following capabilities. It should have auto generation of unit test scripts. It should give the capability to record and playback feature for fast generation of the test scripts. Execution capabilities of test scripts on remote devices connected OTA to test servers. Capability of accession of test cases on the server side rather than overloading the mobile device and generating the reports on a remote server. It should also provide ease of integration with open source tools so that it becomes easy to adopt. Having covered all this, we came to a very critical slide which I will share with you now. A failure-proof way to automate the testing of your mobile solution. We call this approach M-Automate. The approach that we use and recommend is a functional testing automation approach based on our MTA library, where we created hooks within the current application and the test to insert and capture all the events. We measure the impact on all the display-worthy objects on the mobile screen. This can be achieved by following few steps. The first step is ensuring that the mobile client application is rebuilt with our platform-specific MTA library enveloping the main displayable container to create a deployable test app. The second thing that we do is to execute the test app on the mobile device in a record mode so that all the user events and their impact in the normal flow of the app are recorded by our MTA library and sent to the test engineer system in the form of some XML data. This XML data is then converted into a Selenium test script and sent to the Selenium ID, where these test scripts are further modified in offline mode and more test data and scenarios are created around it and placed in some test script repository on a server. Now when the test engineer wants to execute the test cases on any of the remotely available device, using the framework, he can send a push message to a device where the application will be installed, launched, and the MTA library will fetch the test script from the server and execute them. All the events and impacts of the same are again recorded and sent back to the test engineer system, where they are processed by the Selenium server to produce the test results. Let's move to the next benefits of our approach. So this framework provides us key value pairs of the object on the screen for building test scripts by extending Selenium, which is one of the most popular open source tools and easy to adopt and use. Also, the discrete object key value comparison approach is better than the image comparison approach of various VNC-based testing automation solutions. Here the test scripts are reusable as they are independent of device resolution, color depth and screen size. This solution works even on a low-end single tasking systems or the single virtual machine based devices like J2ME and Brew devices because it runs in the same VM as the client app. This framework also provides an option to display the mobile screen on the test engineer's desktop as the test scripts are executed on it. Doing this allows us to record the screen transition for offline UI verification that enables the support of UI testing automation with the help of certain image comparison tools as well. Now let's move to some real life examples where we have tried to use different kind of automation tools. So the first case study that I am taking now is about an MCRM project. This is a mobile customer relation solution that we built for one of our clients, which is a leader in innovative solutions for small businesses worldwide. The application was developed in J2ME and BlackBerry platform, which allows a small business owner to manage his customer lists and customer groups, create SMS-based offers and schedule or send them out to the selected customers or the customer groups, track the responses of the offers and provide some useful business promotion tips based on the industry's current trend. The major challenge here was testing the application on various devices and various target networks in different geographies, with possibility of large number of test cases due to various combinations of schedules and offer types which need to be executed with each iteration of the development. With our Selenium MTA-based approach, we were successful in automating almost 90% of the test cases.
That sounds like a great number, Amitabh, but how much does this number differ from the other approaches of test automation?
You will be surprised if I tell you that the test engineers were achieving only 40% of the coverage by initial unit testing, and then they tried some of the VLC-based testing tools where they could automate around 60% of the test cases, but still there were major problems which was due to the different screen sizes of the different target devices, where they need to recreate the builds for different set of family of devices, and even a minor UI change, they were required to re-record the test scripts for all the platforms before actually getting them executed. Let's move to our next case study. This next case study is a workforce management solution on the mobile device. This was developed in parallel on 4 platforms: iPhone, Android, J2ME and BlackBerry for one of our clients who is a leader in workforce management solution globally with around 40,000 medium and large enterprise already using their solution. They started early in this domain with some standalone attendance terminals and deployed web solutions, and now they are coming up with this mobile offering. The application will provide a workforce user as an employee to punch from phone, request schedule change, request time off, and as a manager, he can manage exceptions, he can approve time sheets, he can allow schedule change of his employees. The major challenge was getting the application of multiple devices of different platforms and different networks worldwide. The large number of data-related functional test cases due to combination of test data from timesheets with different pay code, different type of shifts, and various type of time off and schedule changes. The benefits that we got were initially we were able to test only around 38 to 40% of the code using some unit testing frameworks on different platforms. We tried JUnit for J2ME, JUnit for Android, BUnit for BlackBerry and OCI unit for iPhone. And later we quickly moved to our MTF-based approach, which helped us to again reach around 93% of the automation. The major benefit we had here was that initially we used to take around 5 days to test the application on 4 different platforms with around 8 test engineers working on that, and after automation we were able to do it in next few hours. So ladies and gentlemen, this is how we can failure proof your mobile test automation initiative. Let's go ahead with the questions now.
Thanks, Amitabh. Before moving to the questions, I would like to summarize the session that we have today. We discussed test automation along with its benefits, constraints, and some best practices. We also shared with our audience the Impetus and Automate framework and how it can help achieve maximum test coverage. This webinar was hosted by Impetus Technologies. We develop innovative mobile solutions, software products, and technology solutions for mobile products and services companies, ISVs, and technology-enabled businesses. Our expertise spans the domains of mobility solutions, data analytics, large data management, SaaS, cloud computing, testing, performance engineering, and social media, among others. We offer technology expertise on all kinds of mobile platforms and handsets and provide a range of value-added services around the same. We create next-gen mobile solutions that are secure, reliable, scalable, and manageable. Moving on to the questions now. The first question that we have received from one member of our audience is, does M-Automate support multilingual application testing as well as load testing?
Yes, it supports both multilingual as well as load testing. In case of multilingual testing, configurations can be defined by different set of locales for testing. All the application screen controls are accessible to the automation where they can compare strings and the text provided to them. And also the load testing, automation can be configured to execute certain test scenarios, certain test cases, say around 1000 transactions per second by having multiple instances of the automation running from different machines and hitting to the server.
We go to our next question, Amitabh. As we defined various types of testing automation, so what will be the best sequence of execution for successful test automation?
First, as the developer works on the application by creating the software itself, they can do unit testing automation, where they can use tools like JUnit, JMUnit, BUnit, and then they can follow it with the functional testing or the UI verification. A better approach will be to do unit test with instrumentation, and if they can get some kind of automation tool like mAutomate, that would be the best approach.
The next question, Amitabh, does test cases include device profiles, or is it more about the specific application's user case?
So this particular framework we targeted more on the application specific use cases and try to keep it independent of the device profiles.
We'll take another question, Amitabh, right now. Do you have any kind of limitations for executing test automation using mAutomate in terms of platform, device, or environment?
Yes, as mAutomate is still under development, we are currently do not support the platforms like Brew and Palm OS.
Next question, Amitabh. Our audience wants to know if we can test mobile web applications using Selenium.
Yeah, mobile web application can be easily tested using Selenium, but with mAutomate kind of a library when attached or work with Selenium, it allows you to even test the native application on different platforms.
Thanks, Amitabh, and I would now like to thank our audience for their time today. We will be addressing the rest of the questions by email. We hope that this discussion was a learning experience for you and will add value to your mobility initiative. If you have any further questions or want to approach us for a free consultation, you can email us at inquiry@impetus.com or visit our website www.impetus.com. Thank you once again and have a good day. Bye-bye.